We use the word table to mean a lot of different things in Excel. So in this video, we're going to do a quick overview of different uses of the word table. And to start with, we're going to review the what-if data tables that we've used in the past in this semester. So let's say we had a simple little model that takes A, and whatever number we input for A, and B, which is set to 100. And the first thing it does is divides A by B to get a quotient. And the second thing it does is adds A and B to get the sum. So let's say we wanted to see how these two answers would vary based on what was going into A. And so let's come down here and say A could vary from 10 to 20 to 30. We don't need to count by tens. We'll do 40 and 50. And let's highlight those cells yellow to indicate that they are inputs into the model. And then let's talk about the answers we want to get out. We want to get out a quotient and a sum. So we're going to find the quotient by looking in that cell. We're going to find the sum by looking in that cell. Let's highlight those as blue since they're outputs. Now we could do this by hand. We could come in and say if I plug 10 into this cell, then the quotient's going to be 0.1 and the sum's going to be 1/10. And if I plug 20 into that cell, then the quotient's going to be 0.2 and the sum's going to be 1/20. And I could do that over and over until I filled out the table. Or we could let Excel do that for us by highlighting this section, saying Data, What If Analysis, Data Table. In all of these yellow inputs, we would like to go into a column input cell, which is B9. We say OK, then it's going to fill out that table for us with all of the answers from C12 and C14. So to recap the one-dimensional table, we create it by going to Data, What If, and Data Table. It requires one column input cell, and it allows many outputs. Now let's look at a two-dimensional table. A two-dimensional table is also created by going to Data, What If, and Data Table. It requires a row and column input cells, and it allows only one output. So let's say we had the same model. We wanted the same inputs for A, but we also wanted to use B as an input. And let's say we want B to vary from 10 to 50 to 100 to 1,000. So let's color them yellow since they're inputs. Now where do we put the output? We can't put quotient and sum at the top of the columns because the columns represent different values of B. All we can do is choose quotient and put it in this corner. And then copy all this down and create another what-if data table for sum and refer it to J14. Now we have two what-if data tables. We can fill them in one at a time. And of course, the column input cell is the cell where we want to put all of these different values of A. So it's I9. And the row input cell is where we want to put all these values of B. It's I10. And now we see every possible combination of dividing A by B. Similarly, if we want to see every possible combination of adding them, we complete it in a similar way. Probably the biggest pitfall to using what-if data tables is forgetting which is the row and input column cell. So just remember that the cells that are in a row go into the row input cell, and the cells that are in a column go into the column input cell. The other pitfall is forgetting where to put the output reference. So we reference our output in a two-dimensional table in the corner. Because we can only have one, we reference our outputs in a one-dimensional table across the top because we could have as many as we wanted. We could just keep going out to the right. And that's our review of what-if data tables. So let's talk a little bit about how we might structure data on a spreadsheet. If we have data pasted haphazardly around the spreadsheet, we may think of that as information, but it's sure not very useful. So the idea would be not to have it just scattered all around. The idea would be to structure it somewhat so that we could draw charts from it or use formulas to make calculations from it. If I wanted to look at this unstructured data and pull out the average essay score or pull out the average of all the scores, I could do it, but it would be pretty difficult. So let's think about a better way to organize that. A vast improvement would be to line it all up under headers and put the same type of data in each place. Then it would be a little easier to come in here and take an average score. But we could be even more wise about that. We could add a field showing which student we were talking about. And which assignment we were talking about. And what their score was. Then just by rearranging the existing data, we would have something we could work with much more easily. Then, for example, we could take an average of all the scores just by using the average function. Or we could even add an assignment type or category. Then we could use special functions like average if to get the average of an essay. For example, we could say average if the category is equal to essay, take the average score. And notice that 90.555 is the average of only the scores that are essays. Where the overall average was the average of all the scores. Average if is a handy keyword, but we're going to find some better ways to do that with a pivot table here in a moment. Note also that we could sort this data by selecting the range and going to data, sort, if we wanted to sort by score. And we could line the scores up from lowest to highest. So while structuring our data well makes it easier to chart or sort or filter or subtotal, and it makes it well suited for functions like COUNTIF or SUMIF or AVERAGEIF, there are still better ways to do this using a named table. Now let's look at naming a range of data as a table. I'm going to copy this range that we've been working with. And with it selected, I'm going to say Insert Table, or we could say Control T. Confirm that the first row are the headers of the table and not just some student scores. And then Excel, the first thing you notice is it formats everything, shades every other row, and it puts a little drop down button up here so we can sort, we can filter by a certain student. We could do that with any of these. We could have done the same thing over here by selecting our range and saying data filter. We could have gotten those same options. So really all that Excel did was automatically go to this filter option after it automatically formatted all the rows. And those are the two visual things that people really notice that's different about a named table than just a well-structured range of data. But more importantly than the fact that it's formatted or that it has a name are the rules that Excel puts on this table for us. For example, I could come back over here and if I were so inclined, I could delete a couple of scores out of this table by right-clicking and say delete and shift cells up. And look what happens to all these scores. Now 92 is no longer the grade that Mike got in SA3, it's the grade that we think he got on SA1. In fact, some of Mike's scores are now attributed to Sally up here. So deleting data within that column was incredibly dangerous. If I tried to do that in this data table, notice the only delete option that I have is the entire column or the entire row. So there's one fatal mistake that I can't make using a named data table. Right now I can undo this easily enough with Control Z, but imagine if I'd done an hour's worth of work before I realized that I'd made a mistake like that. I would have pretty much ruined the entire spreadsheet. Similarly, if I tried to sort those scores by going to Data and Sort, it's going to warn me. It says, hey, it looks like you're sorting one column within a whole range of data. Are you really sure you want to do this? And if I said yes, it would let me do it. I'd sort by score. And now the scores are all jumbled up beyond recognition, no longer match up to the student. So I'm going to undo that. If I came over here and tried to sort by score, it simply would not let me do it. When I sorted it, it automatically sorted all the rows in the table. Another thing that it would do, if I tried to calculate the overall average here, in the same way that we did before, of course I get the same answer. But notice if I add another score for Mike down here, SA4, and let's say he bombed it, he got a 0 on it, and it was an SA. Didn't change his overall average here because I would have to go up there and change any formula that was looking at that range of data. But if I came over here and said that Mike took SA4 and got a 0 on it, and it was an SA, it automatically changed his score from the 86 down to the 82. Now Mike would probably prefer that I use a range of data instead of a named table because it was left off his 0. Similarly, if I were adding columns to this, any range, any chart, any pivot table that's looking at this data table would automatically expand its range to include the new data. And so that's why it's very important to have a named table. Let's try another thing. Let's say I inserted a column here and I wanted to change the score to a percent by dividing by 100. I can copy that down. What if I came in here and accidentally were messing with this formula, changed my divide to a minus? I would have this glaring error in my column of formulas. If I came over here and tried that in the named data table, not only would it populate all the rows at once, but if I came in and tried to change it, it would realize that I'd changed that formula in the whole column and repopulate the whole column again. Now I could override that by hitting undo, and then I could actually have that glaring error. But what Excel does the first pass is tries to protect me from myself. Notice also as we are putting these formulas in with the data table, it uses this at function, and the at along with the name shows us that the table has named these ranges. We haven't talked about named ranges in here, but I'll do a separate video on that. So these are just some of the benefits of using a named table, particularly the rules preventing mismatch from inserting partial data, deleting partial data, or sorting one column and not others. And just as importantly, automatically updating the ranges in anything that refers to the table, whether it be a chart, formula, or a pivot table. And finally, let's look at a pivot table. A pivot table is simply a way to rearrange data from an existing named table or a well-structured range. And so let's come over here and insert a pivot table. And the first thing that it wants to know is where is the data for your pivot table. So we can use an existing table or range. I could just as easily choose this area as this area. I'm going to choose the named table because that's the better practice. And it asks where I'd like to put it. I can put it on a new blank worksheet, or I can just choose a location on this worksheet. So I'll choose a location on the existing worksheet and say OK. And what it shows me is a blank pivot table and the fields window that allows me to choose each of the headers and drag it into either a row or a column or a page filter or just the values. So let's pull student into rows, category into columns, and score into values. And you see what it does is it adds up Mike's scores by category and then gives him a grand total. It also adds category by student to get a grand total. And so we can tell the total number of points that were earned on all of the assignments. That's not very helpful. We'd much rather see the average. So I'm going to right click, I'm going to left click on sum of score and choose value field settings. And instead of sum, let's choose the average. And now we can come in here and get rid of some of those decimal places. And we can see that Mike had a 69.3 average on his essays, but an 84 on his quizzes for a composite average of 77.9, and so on. So we can look deeper into pivot tables in an additional video, but for now we just wanted to look at the difference between pivot tables, named tables, well-structured ranges, poorly structured ranges, and then the what-if data tables. And hopefully you see that the two on the left have really nothing to do with the four on the right, which deal with tabular data. I hope this overview of tables has been helpful.